Welcome to lesson 10.4 for honors geometry. So today we're going to go over inscribed angles and polygons with regards to circles. So what is an inscribed angle? An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords. So if we take a look at the angle BAD, we can see that it has chords right here, or endpoints. AB is a chord and AD is a chord. So because this is in the circle and its vertex of the angle is actually on the circle, this is considered to be an inscribed angle. So remember, our central angles were when we had the vertex at the center. An inscribed angle is when the vertex is on the circle. So the intercepted arc, which is going to be this arc right here, that's made by the angle, is the arc of the interior part of the inscribed angle. So arc BD is the arc that is made by the inscribed angle, angle BAD. So we have a theorem, of course, about all of this. And theorem 10.7 states that the measure of an inscribed angle is 1/2 the measure of the intercepted arc. So for example, if we happen to know that this arc right here, let's say it has a measure of 60 degrees, then the measure of the angle, so angle BAD, would equal 1/2 of that. So 1/2 of 60 degrees, which is 30 degrees. So this angle right here is 30 degrees. And conversely, we could also say if we know this angle is 30 degrees, then the arc BD would be 2 times that angle, so 2 times 30, which is 60. Okay, so let's move on to the next slide. And this lesson, we have a lot of theorems that we're going to go through. So we just learned one theorem. Here's our next theorem. So theorem 10.8 states that if 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. So we can see here we've got 2 completely different angles. There's angle BFD and there's angle BAD. But if we notice, these angles both have the same endpoints or same intercept of the arc. So this arc BD is the same arc for both angles. So if this arc is the same arc, then we know that these 2 angles are congruent. So angle BFD would be congruent to angle BAD. Okay, so now let's move on to the next slide. Inscribed polygons. And you guys have actually dealt with this before when we had a circumscribed circle or a triangle inside that circle. So what is an inscribed polygon? An inscribed polygon is a polygon whose vertices all lie on the circle. So all of the vertices of the polygon are going to be on that circle. And a circumscribed circle, which you guys are familiar with, is a circle that contains the inscribed polygon. Okay, so we have a theorem, of course. And Callahan, this one's specifically for you. We've got this theorem, theorem 10.9, that says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of a circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. Okay, lots that's written down there. You don't need to write this whole entire theorem down. What it's saying is that if we have a triangle inside of a circle, so it is an inscribed triangle, and specifically if we know that this segment AC, or the hypotenuse of this triangle, is on the center of, that's a random dot there, but it's on the center of the circle, and specifically the AC is a diameter, then the triangle that's going to be inscribed in the circle is a right triangle, no matter what. It's the only type of triangle that can possibly be inscribed in a circle if one of the sides is the diameter. So we've got AC here is a diameter. Therefore, triangle ABC is going to be a right triangle. And that's what theorem 10.9 says. All right, we've got one last theorem here. Theorem 10.10. This theorem states that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So what that means is that if we have a quadrilateral whose vertices are all on the triangle, like we do here, quadrilateral ABCD, this can only happen if angle A plus angle C equals 180 degrees, and if the measure of angle B plus the measure of angle D equals 180 degrees. It's stating that the opposite angles here. So here are your opposite angles. These two angles have to add up to 180 degrees. Okay, so today's a pretty short lesson. That is it. Hope you guys have a wonderful weekend, and I will see you all on Monday. Take care. Bye-bye.